In this video, I wanted to talk about doing conversions between degrees Celsius and degrees Fahrenheit, or vice versa. Now I realize you could do it like this. Hey Siri, convert 100 degrees Fahrenheit to Celsius.
100 degrees Fahrenheit is 37.8 degrees Celsius.
So what we learned is 100 degrees Fahrenheit is 37.8 degrees Celsius. Okay, well, that's one way to do it, and it works fine if you just need the answer. But if you need to develop some kind of insight about how this process works, it doesn't let you know that. Okay, and so I wanted to go into a little more detail and get you thinking like an engineer would think about how you would make a conversion scale like this. Okay, so the things you need to know are that the scales can be derived by knowing the boiling point and the freezing point of water. Okay, so on the Celsius side, what we know is, I'm going to put a mark here, this is going to be 100 degrees, and that's the boiling point of water. Okay, and I need to give myself a little more room, so let me move this down. Okay, and then the freezing point of water in the Celsius scale is 0 degrees. Okay, in Fahrenheit, we know that the freezing point of water, I'm going to scoot this over a little bit more, okay, is 32 degrees Fahrenheit. And the boiling point is way up here. This is not really to scale, but it serves the point. 212 degrees Fahrenheit. Okay, so we have one scale here, and we have another scale here. Okay, so we could take a look at the ratios of these scales and figure out a way to scale things. I'm going to draw lines here that show a scale factor. Oops. Okay, and the scale factor depends on which direction you need to go. Okay, so this is a scale factor that's between these two scales. All right, so on this, the Celsius side, this total distance of degrees would be 100, right? 100 minus 0 is 100. Okay, on the Fahrenheit side, this total distance would be 212 minus 32, and that would give you 180. All right, so if you take that ratio, 180 over 100, all right, you reduce that down, and you get 9 over 5. Okay, so just distance-wise, if I have something on this scale that is 180 in length, and I wanted to move it to the Celsius scale, which is 100 in length, I would need to make that smaller, so I would multiply by 5 over 9. Okay, so going this direction, when I go from here to here, the scaling factor is 5 over 9. If I wanted to go the other way, if I want to go from here to here, it's what I've drawn here. You take 100 and you move it up to, you have to cover more degrees. It's got to cover 180. So you would multiply by 9 and divide by 5. All right, so that's the scaling step. All right, but there's more to it. All right, there's this fact that the boiling point for water doesn't start at 0 on the Fahrenheit scale. All right, so here's what I'm thinking. If I'm going to convert from Celsius, so let's put a dot here for some number on the Celsius scale, I would first scale, okay? So I have this step I'm showing as scaling, and what we know is that scaling, since I'm going in this direction, I need to cover a larger range. that would be multiplying by 9/5. Okay, so I'm going to call this TC. All right, so I would take TC and I'd multiply by 9 divided by 5. Okay, from here though, I have to also do a shift because this starts at 32, it does not start at 0. So I would add 32 and I would get the conversion factor to TF. Okay, so that's the formula, and you know that goes from the Celsius scale to the Fahrenheit scale. All right, let's think about the other direction. Okay, with the other direction, I'm going to change to red. Okay, in the other direction, I would need to shift first, right? Because I'm at 32 and I need to shift this down, this scale factor down. So I would need to shift, and that means subtracting by 32. Okay, so if I had a number over here, TF, the first thing I would do is I would take TF and I would shift it down by 32. Okay, and from here I need to scale it. Okay, the scaling, and remember I'm compressing this scale so that in some sense the numbers get smaller. Okay, so to compress it, I would multiply by 5 and divide by 9 to get TC. Okay, so those are the formulas. You can then apply that to get any conversion that you would like. Okay, so I just did the one on Siri. All right, if I take TF to be 100 degrees, I subtract 32, multiply by 5, divided by 9, and I should get 37.8. Okay? All right, so that's how that conversion works. Okay, one last word of caution that I want to tell you about. Okay, it turns out sometimes what you're looking at when you apply engineering formulas is temperature differences. Okay, so with a temperature difference, it's tempting to just plug into one of the formulas. Let's say that we said that the change in temperature is equal to 10 degrees Fahrenheit. Okay, the question would be, what is the change in Celsius? Okay, so it's tempting to just plug that 10 into the formula. Okay, plug the 10 into which direction would we go? You know, we're talking about changing from Fahrenheit to Celsius, so it's tempting to just plug the 10 into here. Okay, but that would be wrong. All right, so it turns out that whenever you do differences in temperature, the scale factor cancels in both directions. Okay, so the only thing that matters is the scaling. All right, so you can try this on your own, but you know, one thing to do would be, well, how would you get a change in temperature of 10? You could start with 100. Okay, and then if if that was Fahrenheit 1, 100 degrees, and Fahrenheit 2 would be 110 degrees, you could plug in each of those and get C1 and C2. Okay, so let's do that. Hey Siri, convert 100 degrees to Celsius.
100 degrees Fahrenheit is 37.8 degrees Celsius.
Okay, so we already knew that actually. Now, hey Siri, convert 110 degrees Fahrenheit to Celsius.
110 degrees Fahrenheit is 43.3 degrees Celsius.
Okay, Siri, what is 43.3 minus 37.8?
43.3 minus 37.8 is 5.5.
So the difference, the delta in temperature for the Celsius scale is 5.5 degrees. What if we'd plugged that into the formula? We would have essentially been saying, hey Siri, convert 10 degrees Fahrenheit to Celsius.
10 degrees Fahrenheit is minus 12.2 degrees Celsius.
So minus 12.2 is clearly wrong in this case. All right. What went wrong is you can't do differences using that formula that's in the purple box. All right. So it turns out differences are simply the scale factor. All right. So if I had 10 degrees on the Fahrenheit scale, remember the Fahrenheit scale in some sense is longer for the boiling point range, or the difference between boiling point and freezing point. So if I want to convert that to Celsius, I need to make that smaller. So I multiply by 5 divided by 9. Okay, and so if I do that math, hey Siri, what is 10 times 5 divided by 9?
10 times 5 divided by 9 is about 5.5555.
10.55 degrees. Okay, so in the previous answer, we rounded off too early. These answers actually match. Okay, so there's some insight into temperature conversions. I hope that's useful, and I'm not sure how you feel about this looking at it. Are you totally lost at what I was doing? That's okay. You just try to follow along the best you can. Remember, we're working our way up this Bloom's taxonomy pyramid. You know how to convert these temperatures, file it away as, if you do a temperature difference, you have to be careful with it. Come up with 2 different temperatures that have that difference and then convert it. Those are the things that I want you to have as the takeaway from this video. All right, trying to figure out what I'm saying. If it doesn't make total sense, don't sweat that detail just yet. I just want to get you thinking the way that an engineer would think.